Hi, today I am going to demonstrate the Kickstart software version 2.6.0 with Keithley 2612B source meter. This is a common software for many instruments from Tektronix and Keithley, including DMM, power supplies, data acquisition systems, multimeters, then specialized products like high resistant meters, dichometers, etc. So these are the different models it can provide support, and these instruments can be controlled, configured for data logging with this particular software. This is the direct link to download the software. You can see in.tech.com/software/kickstart slash 2-6-0. So before downloading the software, you must have a Tektronix account with which you can directly download it to your PC. For downloading it, I just need to log in. I'm just providing my login credentials. Yes, now it is ready for download. Since I already have the software installed in my laptop, I am just opening the software. So you can see it is a 2.6.0 version. Yes. So I have a source meter model number 2612B from Keithley. This is connected through USB connection, and this is a dual channel source meter. It can source and measure simultaneously on both the channels. So a typical application will be the transistor or MOSFET testing, where you need to source and measurement simultaneously. As I mentioned earlier, this software is common for many instruments from Tektronix and Keithley portfolio, especially the data logger. It is a it's an app used to control the data logger from Keithley, like DIQ 6510, 2700, 2701, like that. So this will be easy to configure the data acquisition unit through the software, and continuously log the data into the PC. Then next is a DMM app. This can be used to control and data log the DMMs from 5.5 to 7.5 digit DMM from Keithley. Next one is high resistivity. Yes, this is a app to control the 6517B, 6514B specialized kind of resistance measurement instruments from Keithley, and it can even do surface and volume resistivity measurements through the suitable test fixture. Next is power supply. Yes, some of the power supply has access to this Kickstart software, and that is quite easy to configure the outputs with the variable sweeping, desweeping, biasing of the current and voltage, and log the data also. You can continuously log the current consumption of your device on the software. Then oscilloscope also has access to this software, where you can data log different parameters from the oscilloscope input channels, just like maybe from channel 1 you can log frequency, period, peak to peak, rise time, like that. Next one is IV tracer. So this is a typical software which will give the feel as if you are using a parametric curve tracer. This is also available, and it will have a support to the latest generation touchscreen SMUs from Keithley, like 2450, 6061, like that. So here I have a 2612B dual channel SMU, and I am just going to access the instrument. After double clicking that, I can get the IV characterizer app. So there one new window will pop up, and where you can configure the input output parameters. So this will be the landing page after we select the IV characterizer. And as I told you, we have two channels here, channel 1 and channel 2. Since I have a diode connected to channel 1, I am not going to use channel 2 here, and I just disabled it. And yes, now only channel 1 is selected. You can enable or disable any channels in any configuration at any point of time, depends upon the requirement. Now only SMU1 will be used for the source and measure. So the type, first of all, this particular instrument has both the DC as well as pulse configuration. The difference between DC and pulse is, in DC configuration you can make bias and sweeping of outputs and like voltage and current, and you can do the measurement, whereas in pulse you can provide the output voltage or current in terms of pulses, and current is available up to 10 amps in pulse mode, but 1.5 amps in DC mode. So pulse will be used to test the devices which needs a faster response, and especially the memory testing, or the samples which are easily get heated when you apply a continuous DC signal. So these are the two available modes, and you can select DC or pulse. So I have selected DC only here, and I am going to do a forward bias characterization of a PN junction diode. Next is function. Yes, as you know, this source meters can be used to source either voltage or current. If we source voltage, it will measure current, and if we source current, it will measure voltage. So I am going to do the forward voltage to the diode, so I am using this voltage function. Mode 1, a type of output you want to create from the source meter. So it has three modes. One is the bias, second one is sweep, and third one is list sweep. A fixed value source, where whatever you set in the level, it will be continuously applied to the source. Next one is current limit function. So through which you are actually limiting the output current or power, and what is the maximum power the device can be consumed. So by default it will be 0.1 amps. You can change it from microamps to 1 amps or 1.5 amps. And after selecting level, you can configure how many points or how many readings you want to measure with the 1 volt source. So this is the area to enter that particular count. So maybe if I need a 100 readings by applying a 1 volt source, I can just enter 100 here. So it will take 100 readings and stop. Then these are the source settings window, and this is a measure setting window, where voltage and current will be selected by default, and you can even select power and resistance measurements. So here also you can specify a particular range, or you can put the auto range function. And auto 0, auto 0 is before making a measurement, the instrument will first make the output 0 and take a measurement. So it's actually a feature. 2-wire 4-wire configuration is also available. The default configuration is 2-wire. You can still use 4-wire configuration when you source a current and measure voltage. So this has significance when you measure a very low resistance or high conductive samples. So where you can source the current through force high and force low, and measure the voltage through sense high and sense low. And high capacitance mode is also available. High resistance measurements and all, this is really mandatory, because the output voltage to the device will take some time to energize it in the full level of the output, and then taking the measurement. So some algorithm is written inside the software that will do the sourcing and delay kind of things. And NPLC, this is actually nothing but number of power line cycles. So what is the integration time you want to apply in this particular test? So 1 NPLC means 20 milliseconds will be the integration time. You can change it from 0.001 to that means 20 microsecond will be the integration time. Then it can go up to 10, I think, 200 milliseconds. So update rate definitely will change, the speed will definitely change, but accuracy will be slightly improved if you make a higher NPLC measurements. So I am making it in 1 NPLC, that is a default value. So sweep points, 100 points. Okay, here actually I have selected only bias, and if I hit run button, I will get the status here, and I will get all the data in the table with the timestamp. Yes, I got time, voltage, current. Since I selected power and resistance, I got the power and resistance also in this. Now I just want to change the mode to sweep so that I can sweep it from on the voltage level. So I am just making a voltage from 0 to, and I am limiting the current to 0.01 amps. So keeping the other settings as it is. Now I can run the sweep. I mean, here again the step voltage will be 20 millivolt because 100 points has been selected. If I need final resolution, I can even make it to 1000 points. So it will be 2 millivolt, 0 to 2 volt in 2 millivolt step, and each step the instrument will take a current reading also. Now if I go to graph and I hit the run button, it will process the sweep and take the measurement. So we can see that it is gradually increasing, and it's a PN junction diode, and yes, it conducted close to 700 millivolt, that is 0.7 volt. So these are the graph, this is the graph, and this is the reading table. I got all the 1000 readings in a very short time, very short time. So in the graph we can zoom a particular area by just simply doing this, and I can, if I point this mouse onto a particular point, it will show the voltage and current at that particular point. Even if I wish to put a cursor there, I can put a cursor by making a right click. Then if I put another cursor here, I will get the delta value between the two. So this is quite easy for you to make the rise time measurement by applying the cursor at 10% of the rise and 90% on the upper portion. To see the entire wave graph, you can click on here and it will be available here. So with which you can simply make a sweep output and measurement also according to it. Now after you take the measurement, you will be able to see the number of runs, how many runs you made, everything will be available in the run history. So right now the second run, that means run 2, is selected here, and if I want to see the run 1 again, I can make it. So this was run 1, and if I anyway I wish to make one more run with less number of points, maybe 100 points, and I'm going to select sweep here, and I'm going to see from 0 to 3 volt maybe, right, and 100 number of points. If I run it, I should get run number 3 here, yes. So I can see the graph of run 3 now. So you can see this is highlighted. So if I want to compare run 3 and run 2 by simply hitting on control and selecting run 2, so yes, it overlapped run 3, and I can see this blue is run 2 and red is run 3. So I can simply compare by making multiple runs and see the performance of the device over a period of time. And this is run history. Then next one is exporting the data. Yes, of course, after run a particular test, most of us will be interested to export the data. So the data can be exported in CSV file or Excel SX format, and even graphical also you can export in a very nice resolution. And this is a default path. Kickstart in Kickstart projects, there will be a folder to save the data. You can select it to any path in the PC, whichever you want, and you can export the selected runs. Now I have selected run 2 and 3, it will export only run and 2. If I export all runs, then from 1 to 3 everything will be exported with the different file names into that particular folder. Now after making a particular settings and run, if you wish to save this project, you can save the project by giving a name, so that next time you just need to recall the same project with the same settings, and need not to spend much more time to configure the SMU part. So this is quite simple and easy to use. Feel free to inform for any support on the usage of this particular software. Thanks for watching.